Great, good afternoon, and again, my name is Steve Paulhus. I'm part of the Strategic Business Development Group at Xyratex. Over the last several years, I've been meeting and talking with key HPC end users around the world, not only to understand their current storage issues with regards to HPC, but also the requirements going forward. So as part of this vendor update, this title is very appropriate in terms of breaking the I/O bottleneck. We're not talking about 2 years from now. We're not talking about exascale. This I/O bottleneck exists today in HPC systems, right? Not only in petascale, but as well with several teraflop systems, right? They're all starved for data. Our colleagues in the compute side of the house continue to ship and deploy more CPUs, more sockets, more cores. And as a result, those cores are starved for data. So again, this is not only a petascale issue, this is also an issue with several hundred teraflop systems. They're starved for data. So we've all seen the charts. And again, this issue with an I/O bottleneck in HPC is not just for a top 10 problem, right? This is a problem for the top 250 today, and it's going to get worse. So today you've got, within the top 10 systems greater than 1 petaflop, right? You've got within the top 120 systems that are greater than 100 teraflops. Even the slowest system in the top 500 is 50 teraflops today. And we can see what that is. Sorry about that. And as well, going forward, I think we had someone present earlier today that in the next several years, we're going to see systems in the 20 to 30 petaflops. So just think of the I/O demands that that's going to place on the storage infrastructure. So in essence, the deployment of CPUs and cores is far outpacing the available storage I/O bandwidth that exists today in HPC. And as a result, if you look at today, and we look at the requirements that we're getting from vendors today and key end users. So for every petaflop, they're looking for 100 gigabytes a second in sustained file system bandwidth. That's not block I/O. That's sustained file system bandwidth. So today, requirements for the top 120 systems scale all the way up to a terabyte per second. As well, we're getting help from the interconnects, right? So we all know the roadmaps for the high-speed HPC interconnects. They're providing bigger, faster pipes from the compute back to the storage. So the bottleneck truly exists on the storage side. So here's what we have today. This is a traditional HPC storage architecture where you've got your file system nodes that sit above the storage connected with an external fabric to a couple of RAID heads that then are expanded with JBODs sitting behind those RAID heads. And in this configuration here, which is very traditional, there is a fixed amount of network bandwidth, a fixed amount of compute and RAM, and as well, hard drives with the initial configuration. And as this system scales, you can see that all it scales is the number of hard drives. The available RAM, the available compute, the available network bandwidth is not scaled. And as a result, in a 42U rack, 2 floor tiles, I think Brent mentioned it earlier, the top vendor today is generating about 10 gigabytes a second in throughput. So when we looked at how are we going to do things differently to meet the I/O demands of not only today's compute clusters, but tomorrow's, we've got to change it. We've got to change the game completely, whole different paradigm change to the way that you implement HPC storage. So it's really a two-pronged approach. The first is a level of integration where we take the file system nodes and the external fabric and we integrate that along with the drives. So we combine that into one unit. That's a unit that we call a scalable storage unit. Okay, so that scalable storage unit includes all the compute, all the RAM, all the network bandwidth, as well as the drives. And that's illustrated here. So as we scale the system, we scale everything in a linear fashion. And as a result, in that same 42U, 2-floor tile footprint, we're generating 2.5 times file system throughput than the existing systems that are out there today using that traditional scaling model. So we're doing over 24 gigabytes a second with that SSU approach. And as you look at how we scale, we've got a rack here with up to 7 SSUs. We're using 3 terabyte drives here, the upcoming 4 terabyte drives later this year. You can see that not only do we scale capacity in a linear fashion, and in a full rack configuration, you're getting somewhere between 1.7 petabytes and 2.2 petabytes raw, but we're scaling throughput in a linear fashion as well. So it truly scales out and across. In addition to scaling in terms of performance, there's also a TCO play, total cost of ownership. So here what we've done is we've taken a traditional HPC storage system versus this dynamic scaling approach that I've introduced, and we've taken it with a 1 terabyte per second file system, which is, as Brent said, there's going to be 3 deployed this year. And you can see the numbers. Based on the way it scales, you can see the differences. 35% less racks, 34% less data center footprint, 54% less drive enclosures. Look at the number of drives. So again, that's not only a capital expenditure with all those extra drives, but even with an annual failure rate of 2%, which is phenomenal, you've got 3 drives a day failing. You've got an OST rebuilding constantly. Okay, additionally, you've got power savings, cooling. So again, even with a several teraflop system, you're going to have the same types of percentages here. These numbers will change, obviously. But you're still going to see the cost savings, the TCO savings, give or take 2% on that row. So again, the dynamic scaling approach is exponentially less cost, space, cooling, and power. Okay? So again, we see 3 advances that need to be made to answer and satisfy the upcoming storage I/O requirements for petascale systems. We talked about it today with reduced latencies, increased levels of hardware and software integration, dynamic scaling, and a reduced footprint. From here, we'll scale into a little bit now about, or transition into a little introduction into ClusterStor 3000, which is, as vendor update, our little commercial. So here is where we've taken the approach that we've just introduced to you, and we productized that as part of the ClusterStor 3000. Here is a view of our SSU. It is the densest enclosure on the market today. It's a 5U 84 drive enclosure. I won't go through all of this in the essence of time, but we've built in unbelievable amount of SAS bandwidth in this enclosure, so that as we integrate more and more SSDs going forward, we'll be able to take advantage of those performance enhancements. Each SSU generates about 3.5 gigabytes a second in file system throughput. This SSU is completely redundant, completely high availability. All of the components are hot swappable in the rear here. As well, on the 3000 class, in terms of network connectivity, we've got dual QDR-IB, and as well, we've got dual 10 gig E outputs. The back end is 6 gig SAS. When you take out the hot spare drives, the RAID overhead, and the SSDs that we incorporate 2 SSDs within this SSU to further augment performance, you're left with about 64 usable drives, and depending on the drive capacity you use, you can see how that scales in terms of SSU, in terms of capacity. If you look at rack scale from an overview from a ClusterStor 3000, it's targeted at over 20 gigabytes a second per rack. That's 2 floor tiles. Overall performance, when you concatenate multiple racks, is over 100 gigabytes a second, over 30 petabytes of storage. If you look at some of the key metrics within the rack, we've got up to 560 hard drives, 2.2 petabytes of raw storage with 4 terabyte drives, up to 14 embedded servers per rack, and as well 14 high bandwidth network connections. Now, as Torben introduced a little bit earlier, this rack is fully integrated with everything. You don't need external file system nodes, you don't need external switches for either InfiniBand or 10 gig. They're integrated into the rack, and as well there's a private management network switch, of which we do our own management, GUI-based. Again, bringing that usability into Lustre, getting it out of that science project mode. And as Brent mentioned earlier, right, it's not only for the top 500. We truly believe that Lustre now can be further adopted in the industrial markets and into smaller markets that in the past wouldn't have considered Lustre. We leave the factory fully configured. meeting or exceeding the customer's capacity requirements, performance requirements. We do up to a 30-day soak test. You've seen what we've done with the shake test. And in terms of usability, right, I mentioned we've got a user interface, a GUI that we ship with the system. But when you compare the Cluster Store out-of-box experience with traditional Lustre implementations, you can see where we're different, right? We've got a simplified configurator model, single vendor, capacity, performance, all the components come from Xyratex typically, and you don't have to do the installation on the data center floor. It's not the first time the rack comes together. That's all done in our factory. You look at software integration, up to 5 days on your data center floor. Again, we do it in the factory. We're up and running in less than 4 hours. All of the performance tuning is done in the factory. We can add multiple racks in the future to increase your file system capacity. Again, it's less than 4 hours of implementation. And in terms of your acceptance tests as HPC end users, it's greatly shortened. Again, from the dock to your data center floor, we're doing I/O in a matter of hours. So, short commercial on Xyratex, who we are. Again, you might not have heard of us. We're the world's largest OEM storage provider. We've got 7 of the tier 1 customers in the world. They put their badge in the front of our hardware. I think Torben went through some of our key metrics here in terms of we shipped 4.1 exabytes last year. We shipped that 1 millionth enclosure last year. So we've got 25 years of history in innovation in storage technologies. We've got, again, the who's who of customers in terms of our OEMs. As well, my role at strategic business development, in addition to working with key HPC end users around the world, I'm also working with our OEMs and making sure that the requirements that we're hearing from key end users around the world are folded into our products and then pushed out through our OEMs. In terms of Xyratex, we're not new to HPC storage, right? So we served the HPC storage market in the past through our OEMs, but it was mainly through hard drives and enclosures. What's different with cluster storage is now an HPC solution from top to bottom. So it's the drives, the enclosures, the file system, the management framework, all integrated into the rack. We continue to make investments in this. At Supercomputing in Seattle, we were nominated as one of the top 5 vendors to watch this year in HPC. We continue to invest in this business. We made a small acquisition in 2010 of a company called Cluster Store, which has become our brand now. That company was headed up by Dr. Peter Brahm, who was the founder of Lustre. And we've got Peter Brahm, as well as his team, a lot of his key architects and developers now working at Xyratex. So we are a fully fledged organization in terms of being able to support and develop Lustre capabilities. Long-term commitment to Lustre, and as well, what is our position on Lustre? Right? We've got several roles with Lustre in the community, right? We're a strong proponent of the open source community. We're dedicated to that. We are a board member of the OpenSFS organization. We're one of 5 board members. So that's Xyratex, that's Cray, DDN, Oak Ridge, and Livermore. Each company contributes $500,000 a year towards Lustre development. So right there, you've got $2.5 million of development dollars that are being poured into Lustre development, in addition to our engineers also working on Lustre in addition with other companies. We're also, and as well, we're a member of the EOFS sister organization here in Europe. We're an active contributor to the Lustre roadmap and source code. We've also taken that a step up in integrating Lustre in the whole solution with our Cluster Store solution. And then lastly, we've got a Lustre support services component to our offering, where we will not only support Lustre on our hardware as part of Cluster Store, but we'll also offer Lustre support on third-party hardware and multiple software releases of Lustre. In closing, we think we are the future of HPC storage just by the way we integrate, the way we scale, the TCO savings, and as well the Lustre expertise that we have in-house. Any questions?